Resonance in series RLC circuit by using MATLAB. Here, this is one of the simple circuit. It is having resistance is called 2 ohms and inductance reactance. Inductive reactance is equal to 10 ohms and capacitive reactance is called 10 ohms. So voltage across the resistor is called VR and inductor VL and VC, and then supply voltage is called 10 volts at an angle. Okay, and then they call one simple series RLC circuit. And then we know under resonance condition, inductive reactance and then 5,000. That is 5,000. And I is equal to and PC equal to PC like this. And we are like go to MATLAB, open MATLAB, and take AC voltage source. From the library, select one AC voltage source. AC voltage source. So this is called AC voltage source. And place here AC voltage source. This is called AC voltage source. And then they take one series RLC branch. Series RLC branch. Series RLC branch. And copy this this way. And one more element is equal. This is for R. Change the type R. Apply. Okay. And then L. Apply L. Apply L. And then okay. Then C. Select type C. Apply. Then okay. Then select this. Press Ctrl R. And rotate like this. And connect AC voltage source to the R, L, C, and this way. This is called series RLC circuit connection. Then if you want to measure the voltage across the resistor, take one voltage measurement, and also here also take one voltage measurement. Voltage measurement. Voltage measurement. Connect parallel to the resistor. Okay. Connect like this. Voltage across the resistor. Okay. And then next similar way, voltage across the inductor, voltage across the capacitor, and voltage supply voltage also. This is called connection. And connect in this way, same way across inductor also. So this is called measure voltage measure across the inductor. And a similar way, voltage across the capacitor. Connect like this. Voltage across the capacitor. And also source voltage. Source voltage. Voltage across the source voltage. Then take one display, otherwise scope. Scope, open scope. Select scope. Take scope right here, scope. Take scope and place here. So how many, and also here one current source is also required to measure the current. Take one current measurement. Current measurement. Current measurement. Connect in series with the source or load resistor. Connect positive here and then negative. Okay. Current measurement used to measure the current. And here, how many displays are required? How many ports is required in scope? First one, voltage source, VR, VL, VC, and L. 1, 2, 3, 4, 5. 5 ports are required. That's why open scope, and select number of input ports is equal to 5. Go to press here, open scope, and change number of input ports to 4. Number of input ports is equal to number of input ports is equal to 5. Then okay, and close. This is our scope. Okay, here first is called VS. Second one is called, for example, VR. And third one is called current. Fourth one, VL. Fifth one, VS. Like this. First VS, second VR, so third I. Then last VL, VC. So like this connection. From this example, what is the resonance frequency here? By substituting the values of L and C, then we will get resonance frequency is equal to 5000 Hz. So 5000 Hz here. Resonance frequency right here, 5000. 5000. For example, peak amplitude here, 10. Apply, then okay. This is our connection. And change the values of resistance. How much resistance here? How much resistance? Here resistance is equal to 2 ohms. Resistance is equal to 2 ohms. Yeah, right here, 2 ohms. Apply, okay. Right here, series RLC, 2 ohms. Like this, resistance is equal to 2 ohms. And inductance is called, how much here? Inductance, reactance. Inductive reactance is equal to 10 ohms. So calculate inductance XL is equal to omega L, that is equal to 10 divided by omega, that is equal to 2 into pi into L. L is called, we have to calculate frequency 5000. XL is equal to omega L. L is equal to XL divided by omega. Omega is equal to 2 pi. 2 pi into 5000. 10 divided by 2 pi into 5000. That is equal to 3.18 into 10 to the power minus 4. Right here. 3.183 into 10 to the power of minus 4 is called inductance. Apply, then okay. Inductance is our, inductance here how much? Right here, 0.3183 millihenry inductance. The next capacitance. Capacitance, how to calculate capacitance? X is equal to 1 by omega C. XL is equal to omega L for inductance. X is equal to 1 by omega C. So X is equal to C is equal to 1 by omega into omega is equal to pi. Okay, XL is equal to omega L, that is over. Then coming to the XC, XC is equal to 1 by omega C. Here C is equal to 1 by X into omega. C is equal to 1 by XC, that is called 10 into omega, that is called 2 into pi 2 into pi into frequency 5000 Hz. 1 by 10 to pi into 5000 is called 3.18 into 10 to the power of minus 6. 3.18 into 10 to the power of minus 6 microfarads. 3.183 microfarads into 10 to the power of minus 6. Okay. Right here, C is equal to how much here? 3.18. 3.183 microfarads. This is called capacitance. And supply voltage is called P, amplitude is called 10. And frequency, resonance frequency 5000. And resistance 2 ohms and inductance 0.3 millihenry. And the microfarad is 3.183 microfarads. And then simulate, and then open a scope. So 2% is completed, and then it will open suddenly. It will take power guy, otherwise you will get errors. Take power guy also from this library. Power guy. Take this power guy place here, and then here right here our frequency 5000 Hz. That's why time 1000 by 5000. So right here approximately 0.002 for 2 seconds, 2 cycles. Okay, simulate 0.002. So for 1 cycle, then open scope and change separate blocks like this. It's taking some time. Change sample time to 0.0001. Then apply. Okay. Apply. Okay. And then simulate. Again simulate. So here frequency 5000. That's why right here stop time is equal to 0.001, and then simulate, then open and display like this. So first one is called supply voltage, and then second one is called uh, VR, voltage across the resistor, and third one is called current. Fourth one is called VL and VC. Change style, change background color. There's a graph this way. Change background into white. Axis color is also white, and this is called black. And active display one display, active display one. Change background color is called white. And then play 2 and change this, apply, and okay, it will be changes like this. And then similarly active display 2 also, active display 2, change the thickness 2 and change the color to another pink color, then apply. Okay, this is called active display 2. And then similarly for all active displays 3, 4, 5, select one by one. 3, and change color and change also thickness, and then apply. And then as active display 4, change color and also thickness, then apply, then active display. Then as last one, final active display 5, change the thickness is equal like this. Color also, colors and thickness both are changing. This is called supply voltage. Supply voltage, this peak amplitude is called 10 volts, and this is called VR, voltage across the resistor. So by observing these waveforms, VS, VR, both are in phase. Under resonance condition, VS and VR both are same. Okay. Under resonance condition, what is the voltage across this resistor? 10 at an angle of 0. Okay. VS also 10 at an angle of 0. That's why under resonance conditions, same amount of voltage can be, this is called VS and VR. Both voltages are same. And then next, coming to the current, this is third one is called current. Third one is called current. First one, this is called first one VS, and second one VR. VS, VR are both are in phase. That's why. So what is the voltage waveform? Same also current VR waveform is same. VR and VS are both are in phase. Then coming to the current, under resonance condition, XL is equal to XC, and this will become 0. Only resistance present. Current I is equal to V by R. Here peak amplitude is called 10. 10 by 2 is called 5 amps. Okay. So current 5 amps. Then that is called current I is equal to 5 amps like this. This is called 5 amps. Current waveform. And both voltage waveform, source voltage waveform, voltage across the resistor, and current under resonance condition, all are in phase. Okay, 3 are in phase. VS, VR, I both are in phase, and also maximum value of current under resonance condition. So this is called current maximum, that is called 5 amps. 10 divided by 2 maximum current, the peak of peak current is called 5 amps. Like this, we can get under resonance condition. Then next, coming to the capacitor, we see VL, VC. This is called voltage across the inductor, and this is called voltage across the capacitor. Voltage across the inductor and voltage across the capacitor. Final fourth one and fifth one is called voltage across the inductor and voltage across the capacitor. And then here, so voltage across the capacitor inductor is called 50 at an angle of 90 degrees. So that's why we will get like this VL. So here 40 and 60 in between there is a 50 voltage. Okay, this is called 50 at an angle of 90 degrees and 50 at an angle of minus 90 degrees. Okay, that's why we will get in this way. So VL and VC, VL 50 at an angle of plus 90 degrees. That's why in this way it start like this. And VC 50 at an angle of minus 90 degrees. That's why VC minus 50 at an angle of minus 90 degrees, because of this. Both are out of phase. It start from in this way and it start from in this way. So out of this, then VL minus VC is equal to 0. Then only VR present in the circuit, that is called purely resistive circuit. Under this, so maximum current and VS, VR, VS, VR and I are 3 are in phase, and VL, VC are out of phase, like 90 degrees displacement between these two. 90 plus 90, 180 degrees displacement. Okay, this is called VL and VC. Okay. In this case, in this way, we can identify the resonance in series RLC circuit. Okay, and next, and taking one by changing the values of resistance, inductance, capacitance. For this, for resistor is equal to, for another example, for resistor is equal to 1 ohm. Resistor 1 ohm, inductor 10 millihenry, capacitors C 2.53 microfarads. Okay, and the resonance frequency by substituting the omega is equal to 1 by root LC, by substituting the L and C in resonance formula, then we will get frequency is equal to 1000 Hz. This frequency is called 1000 Hz. And then a peak amplitude is called 5 into 1. Vrms is equal to Vm by root 2. Vm is equal to 5 into 1.414. So this is the peak amplitude. Okay. And then frequency 1000 Hz. Then simulate this frequency 1000. That's why stop time is equal to 0.002. And simulate and open scope. First one, this is called Vs. Second one, current. Second one, this is called second one. It's called VR. Third one, current. Fourth one, inductor. Fifth one, capacitor. So open this. First, this is called Vs, VR, and current I, VL and VC. Okay. Here VR is called, V supply voltage is 5 root 2, 5.5 into 1.414. Like this, we will get peak amplitude. And this waveform, Vs waveform, VR waveform, and current waveform, all are in phase, same phase followed. Here start from 0, here also start from 0, start from 0. And here ends at here, and here for positive half cycle. Negative half cycle also changes like this. Same way, positive half cycle, negative half cycle, both are, the three waveforms are in phase. Under resonance condition, Vs, VR, and current I all are in phase. And VL, VCR, this is called VL start from in this direction, VC start from here. That is called, these two are out of phase. Okay, VL and VC are out of phase. That is called VL minus VC will become 0. Only we are present in this voltage drop across the resistor, only present. Okay, so here current I is equal to Vs divided by R. R is called only 1 ohm. That's why. So what is this voltage? Vs is equal to 5 into 1.44. That will be displayed in current waveform also. Okay, then VL is equal to I into XL and VC is equal to I into XC. According to that, we will get to the values of voltage across the inductor and voltage across the capacitor. And also, if you want to display what is the value of inductance, what is the value of voltage, take one RMS, enter fundamental frequency is called 1000 Hz, that is called resonance frequency, and then take one display and connect here. This is nothing but voltage across the VL, supply voltage across the supply. And similarly way, if you want to measure the voltage across the inductor, copy and paste here. So if you want to measure the voltage across the inductor and connect, where is the inductor? This is called inductor. Okay, and this simulate. This is called voltage across the inductor. So 4.98 is approximately is equal to 5. Then similarly, what is the voltage across the capacitor? Connect this and across this capacitor, then we will get same way. Voltage, this is called voltage across the resistor. Okay, this is called voltage across the resistor. If you want to know voltage across the inductor, take one select and copy and delete this. Connect this way. This is called voltage across the inductor and simulate. 313.33. 313.33. 3 is called our inductance. Understood? Voltage across the inductors, that is called VL. Similar way, if you want to know voltage across the capacitor, select and paste here, copy and connect voltage across the capacitor. This is called voltage across the capacitor. And simulate. The voltage across the inductor and voltage across the capacitor both are in phase and opposite. VL is equal to VC here 313.3, here 313. Approximately 3. So both are same voltages. Okay, under resonance condition, voltage also same. Voltage across the inductor, voltage across the capacitor, both are same. Okay. And then coming to these waveforms, so here 313.3, this is called 3 minus 313.3. voltage across the inductor and capacitor changes like this. This is about resonance in series RLC circuit by using MATLAB.